All right, it's just now turned 1 o'clock. We'll go ahead and get started. Hello, everyone. My name is Matt Dielcluse, General Manager of RAECO Rents. I'd like to thank all of you for taking time out your busy schedules to join us for our webinar on tips for collecting better IH data. Anything that could go wrong will go wrong unless you're prepared. Our presenter today is Kay Rowntree. In this webinar, she will cover the following: information needed up front to prepare a good sampling strategy, why industrial hygiene data without contextual information can lead to incorrect judgments about exposures, common misconceptions about industrial hygiene sampling and how they impact sampling and data interpretation, common things that can go wrong during sampling, and then we'll answer questions at the end with Ask the Expert. Kay is the owner of the industrial hygiene consulting firm Industrial Hygiene Sciences in Waterford, Wisconsin. She has over 42 years of experience in the field of industrial hygiene, conducting air and noise exposure assessments, helping employers comply with OSHA regulations, and preparing safety data sheets. Prior to starting her consulting practice, she worked for a workers' compensation carrier for 14 years and the state of Wisconsin Health Department for about 5 years. She is certified by the American Board of Industrial Hygiene in comprehensive practice. She holds a BS degree in bacteriology from the University of Wisconsin-Madison and an MS degree in environmental health industrial hygiene specialty from University of Minnesota. For the majority of her career, Ms. Rowntree has focused on doing occupational exposure assessments in foundries, metal factories, food processors, agricultural heavy equipment manufacturers, electrical component manufacturers, machining operations, construction sites, woodworking operations, waste and recycling operations, chemical product manufacturers, blenders, printing operations, paper mills, plastic manufacturers, concrete, stone manufacturers, utilities, and municipalities. We welcome Kay as a speaker and thank her for sharing her time and expertise with our customers. Now I'd like to turn the microphone over to Kay. Welcome.
Thank you, Matt. Oh boy, it's not advancing here. Sorry about that. The presentation seems to have frozen again, Matt. Just hang on a second. I don't know what's wrong here. Boy, we even practiced setting this up and it's not working. That's unfortunate. There we go.
There you go.
Right. Let's try again here. There we go. Doesn't seem to like when it goes to sleep there. All right, thank you for listening in today. We're gonna talk about, I'm still having trouble advancing it, Matt.
Shoot. If you want, I can run the slide deck.
That would be fine. I don't want to waste everybody's time looking to figure out why it's not moving. So if you mind advancing it, that would be great.
Yeah, give me 1 second. Okay, do you see my screen now?
No, I can't.
Huh. You don't see my screen?
I do now.
Okay. All right, just tell me when you want me to flip.
Okay, we're going to talk today about the importance of preparing well to do an industrial hygiene survey. And I love this quote from one of my favorite heroes, Alexander Graham Bell, that preparation really is the key to success. And hopefully if there's nothing else you remember today, that preparing for good industrial hygiene surveys is absolutely critical. Next slide, please. Getting quality IH data, like I mentioned, it requires good preparation. And I like to start out with emphasizing how important it is to have a sampling strategy developed before you order equipment, before you figure out all of the nitty-gritty details that are necessary to do good industrial hygiene work. Another important thing is knowing how to use the sampling equipment, understanding its limitations, and in my opinion, one of the most important things is making sure you allocate enough time to be out there when the sampling is going on and to do the work that it takes before and after sampling, and then have an idea of how you're going to communicate the results both to management and employees. I think one thing that we tend to forget when doing industrial hygiene sampling is we get all involved in the mechanics of how to work a pump or how to hook up media, and we really forget one of the big overarching things is that when you assess workplace exposures, there's an impact on real people's health when you collect this data. After all, that's why you're collecting it, to figure out, do we have a problem here and we need to fix it. And so when you're dealing with people's health, this data is really important and we shouldn't be taking any of the steps lightly. Secondly, I think another overarching thing that gets forgotten is that you have to live with the data you collect. OSHA has this little thing in 1910, 1020 that says you have to keep these records for at least 30 years. And in addition, you have to notify employees for certain types of things that get monitored. So if you aren't collecting good quality data, you're going to have to live with bad quality data, which could lead you to either spend money where you shouldn't be spent or to not find problems that you should be finding that will keep people healthy. So you can become proficient at handling the sampling equipment. Certainly places like RAECO have videos. They have great behind the scenes people that could tell you how to work the equipment. But the real art of industrial hygiene is this upfront preparation to develop a good sampling strategy. And then at the end, figuring out what the data means and how you're going to interpret it. Next slide, please. So developing a sampling strategy, I kind of put it in the form here of asking yourself some questions. And the first thing I start out with is, what's your goal of the sampling? Obviously, if it's compliance-based sampling where you want to know if your exposures exceed an OSHA standard, you want to know what those standards say. So the first thing you want to do is start out reading those standards and understand what OSHA's requirements are. And they can be very detailed for some standards. If you're doing evaluation of your controls, maybe you want to consider doing a pre-control implementation and post-control implementation so you could see if things are working well. Maybe you want to do task-based monitoring instead of full shift monitoring because you want to identify specific sources or specific work practices or products that drive exposures. That, if you want to do that, that's really a great thing. However, it might change the way that you plan on collecting those samples. The next one is what should be sampled. Sometimes this is really easy. You know you've got substance A, and that's the only substance that's there, and that's what you want to sample. That's wonderful if you have those situations. But in some situations, you don't have that information. And unlike television, there aren't many ways that you can use one device to sample and collect everything. That's not the way industrial hygiene works. So you have to become proficient in lots of things, including what methods out there exist. Are there exposure limits for these things? Are there specific tasks that you want to look at versus doing full shift sampling? And very importantly, which criteria are you going to use for evaluating the results that you get? When you go into the whens of the sampling, this is oftentimes what I find frustrating as a consultant is you get out to a place and you find out, well, that's not exactly what they thought was happening. And that's very frustrating. So I ask a lot of questions when I'm working with clients about the whens of things. When does stuff happen? When do typical things? Are you interested in worst case sampling or just typical sampling? A lot of people want to default to the worst case situations, but however, you need to be prepared to live with that data as well. Defining the worst case can be problematic to begin with, but the other problem is that you have this data point out there which may have high exposures, which doesn't represent the typical day-to-day thing. So you need to think a little bit about that ahead of time. The who gets sampled is also very critical. And also that seems like it would be easy to figure that out. But when you're starting out with surveys, sometimes you know exactly who it is that you want sampled because they're the one, there's one person handling the substance. But oftentimes you have multiple people doing similar jobs. Do you want a representative sample that is that number is supposed to represent many people's exposure? Then you have to start thinking about what does representative mean. Maybe you have a concerned employee who says, I don't know about this, I'm concerned about the exposure. Again, that's relatively easy to address and find that person. Some people like to sample only their cooperative employees, the ones that they know aren't going to give many flack about wearing a sampling pump and that sort of thing. And that's fine. But the problem is maybe that cooperative employee isn't doing the task that you really want to have monitored. And you have to kind of stick your neck out there and deal with people that maybe you really don't want to deal with, but they're the people that are doing the job. So again, it's easiest to default to the cooperators, but you need to at least be prepared that sometimes you gotta cajole people into cooperating with the sampling process. And lastly, who's going to do the sampling? And if you're doing the sampling, asking yourself, do you have the knowledge and proficiency to do it well? Next slide, please. So let's start out with what criterion, and I kind of put this right at the beginning because I think it's really important that you decide right from the get-go what exposure limits you're going to use. And you'll see as I go along in the presentation why this is so important. Many of you may know that there's many occupational exposure limits out there. And sometimes they're confusing. In fact, often they're confusing. They're contradictory. They don't all say the same thing, and it gets to be quite confusing. So it's a couple points I want to get across here. Obviously, the OSHA limits, at least in the United States, are the ones that we have to comply with, right? If you are over the OSHA exposure limit, you've got a problem that needs to be fixed, employees that need to be protected. But there are other limits out there, and they're recommended limits. They are not regulatory, except in the case if OSHA doesn't have an exposure limit for a specific compound, they may actually use some of these recommended limits. The one that I've most frequently run into is with powder coating operations. Many powder coating operation or powder coats have TGIC, triglycidyl isocyanurate, in them. OSHA does not have an exposure limit, but there is a TLV for it, and I've actually seen them reference that when they cite employers for exceeding that limit. So just be aware of that they can do that if they so choose to. Another important thing is to remember that these limits are not all based on the same things, and I'll address that in a few minutes. But these differences will affect how you set up your sampling methods or your equipment. It really drive the length of your exposure time and that sort of thing. I really encourage you that if you're sampling for OSHA, if you're sampling for things that have expanded OSHA standards, these are things like lead or beryllium or hexavalent chromium, formaldehyde, things like that. Those standards have very specific requirements for what methods can be used, how long samples are supposed to be, and how you're supposed to select representative employees. So I really encourage you that if you have not read these standards, that you do that. Usually in the very beginning of the standard, usually section C of the standard, where it talks about exposure assessments, you will find that information. And also be aware that if you're in certain states, there are state OSHA plans that have different PELs than what the federal OSHA has. And again, you need to be aware of that. I had a client who was in Minnesota and hired a consultant out of Arizona, and they ended up referencing the federal OSHA PELs, and in actuality, Minnesota had different PELs. So they thought they were in compliance, but they actually weren't. So it's important to know if those differences occur in your state. Another thing to remember is that OELs only apply to personal breathing zone samples. I do take area samples for distinct purposes, but you can't always take an area sample and just compare it to a breathing zone sample for a myriad of reasons. So I'm always very careful in how I interpret the results from area samples and comparing them to the occupational exposure limits. OELs for noise are especially confusing. There's really three types, and if I see anything, when I review existing industrial hygiene reports, this is what I find to be one of the things that is most often misinterpreted, and I'll address that a little bit towards the end of this presentation. So over on the right-hand side of the slide, we have our regulatory versus recommended limits. If you're looking for a good source of finding out what the PELs are and some of these other limits, OSHA actually has a really nice annotated tables on their website. So if you just search OSHA PELs annotated tables, you will find these, and they will have the ACGIH TLVs as well as the California PELs and the NIOSH REL. So it's a really good place to go to find that. If you're looking for more in-depth information with some of these other exposure limits, the ACGIH publishes a really good occupational guide to occupational exposure values. It's not an inexpensive document, but it's a great resource for these. Another really important thing that you'll hear me talk a lot about is the time period that the occupational exposure limit applies to. And this is really critical because because this will really drive how long you sample and indirectly the flow rates that you might use. And again, this is something that I see oftentimes improperly used when people do sampling. And I'll explain that again a little later, but let's get some terminology down in case you're not familiar with it. The time-weighted averages apply to 8-hour, 480-minute exposures. The practice is that you should sample as much of, your sample should cover as much of that 480-minute time period as possible. And if it doesn't, then you've got some judgment calls to make on what happened during the time that you didn't sample in order to make comparisons with an exposure limit expressed as a time-weighted average. The second one are short-term exposure limits. In most cases, the STEL it usually accompanies a time-weighted average. In other words, there's two exposure limits there, but there are some exposure limits that there are some compounds that only have a STEL. These apply in most cases to 15-minute exposure periods, although NIOSH has some that are 10 minutes to add more confusion to an already confusing subject. So your sample time should be around that 15-minute time period. Now, if it's 20, 25 minutes, it's not the end of the world, but you want them to be relatively close to that 15-minute time period. What I do see people sometimes doing is comparing full shift samples to an STEL or vice versa. You can't do that. They're based on different time periods. You have to follow it. And that flows into the last way, time period is the ceiling limits. These are never to be exceeded numbers. And this can make sampling a challenge. If there's a direct reading instrument that can instantaneously measure the substance, that's my preferred method for doing ceiling limit exposure assessments. But a lot of things don't have that. And so you're stuck with, what do I do now? And the answer, in my opinion, is that you sample for the shortest amount of time that will get you above the detection limits for the method. So sometimes with with chemicals, that may be a 30 to 50-minute time period. It's not perfect, but with the absence of a direct reading instrument, you really don't have another choice. One thing that I run into very frequently with this is that the OSHA PEL for manganese is a ceiling limit. It's 5 milligrams per cubic meter. And I see people all the time in reports doing time-weighted averages. They'll sample a welder, for example, for an entire shift, and then to compare that number with that 5 milligram per cubic meter ceiling level. That's very inappropriate and shouldn't be done. If you want to measure a manganese level, a manganese exposure, and compare it to the OSHA PEL, you have to take a much shorter sample, and there certainly are ways to do that. Lastly, you need to know a little bit about chemistry, I'd say a lot about chemistry, a little bit about physics, and a little bit of math. I know that's not probably what a lot of you want to hear, but again, what I see very frequently done is problems with not understanding some basic chemistry and physical properties of these of the compounds that you're sampling. I've listed some of these before, knowing whether something is a fume or a dust, and I'm not going to go into detail, but fumes originate basically from hot processes like molten metal, welding, thermal cutting. Dust come from almost any other source, including abrasive processes, handling dry materials, and that. Some OELs have different exposure limits for fumes and dust, and you cannot use them interchangeably. And I'll have a good example for that is copper. Copper fume, the PEL is 0.1 milligrams per cubic meter. Copper dust, it's 1 milligrams per cubic meter. So you got a 10-fold difference in those exposure limits. So you need to know where those particles originated, how and where they came from in order to use the correct one. Another example is iron oxide fume. Fumes again are derived from hot processes, so you can use that PEL for welding, fume, molten metal types of exposures. But if somebody's grinding on a piece of metal, that is not creating a fume, and therefore the iron oxide fume PEL is not applicable. And I've seen even OSHA reference the wrong PELs here. So you need to read how the OEL is expressed and make sure that it matches up with your process. Another big area of I guess mistakes where people don't quite understand the terminology is with particulate monitoring and particulate sizes. Particles come in all sorts of sizes, and some exposure limits are very specific. If an exposure limit does not have one of the three designations on the slide, R, I, or T, it means it's a total dust sample. I put total in quotation marks because that's done generally with a 37 millimeter cassette with an opening on it. It's really not collecting all particles, but nonetheless, it's traditionally called total particle sampling. So if you try to collect a silica sample using a total dust sampler, you will have results that cannot be used because the silica exposure limit's based on the respirable fraction. So again, what I often see people doing in their comparisons with with exposure limits when they interpret the results is they're trying to compare particles that are not collected with a size selective device and comparing them to an inhalable or respirable exposure limit. That's not appropriate unless you have some reason for thinking that all of those particles would be respirable, such as in a welding operation. The last one I just want to mention is the valence state for metals. This really excuse me, comes most into play with chromium, and chromium can exist as elemental form, trivalent, and hexavalent, and they have different exposure limits. So it's important to just recognize that that's the case. Another thing is with going back to the chemistry issue is let's take a compound like butyl acetate. There are actually three isomers, N, sect, and tert, and you need to know which one it is. The sample device doesn't care what it is, but the laboratory is going to need to know which one of those you're looking for. So that's where that little bit of chemistry comes into. And lastly, units of measurement. I didn't put this on this slide, but all of these things all of OELs are expressed in some form of a unit of measurement: milligrams per cubic meter, micrograms per cubic meter, part per million, part per billion. Don't mix those up. And this is mostly confusing because laboratories are not always consistent they may be consistent within their laboratory, but the units of measurement may not be consistent with how the published OEL. And the most common one I see with this is silica. The silica OEL is expressed as in micrograms per cubic meter, but some labs are still reporting out respirable silica as milligrams per cubic meter. And you need to know that there's a 1,000-fold difference between that, and it's very easy to mix those up. Same thing with parts per million versus parts per billion. There's a 1,000-fold difference there. Just know what your units of measurement are from your laboratory and know what they are for the exposure limit so you don't mix them up. Next slide, please. So let's start in the sampling strategy steps. I've just kind of outlined, what I like to see when I do a sampling strategy, because I think trying to look at these steps will help prevent problems in the field. And trust me, I've made my share of errors over the years, and I still never cease to be amazed at what one assumes to be how things are out in the workplace isn't always the way that you think they are. So having a very open mind about things and being able to be flexible and adjust on the fly is very, very important. So let's talk about safety data sheets just briefly. That's going to be your main source of information. If you find out what it is you're sampling for, you can determine if there is an exposure limit in the sampling method. There's a lot of stuff that has no sampling method, and you might have to use a qualitative method of assessing the exposure instead of a quantitative method. So what can go wrong in this step? Well, the most common thing I actually run into is that the safety data sheets that my contact or whoever it is supplies to me aren't the products that are actually used in the plant. And so it's really critical that when you're doing the sampling, you got to go with what's given to you, unless you have the luxury of going out to and doing a walkthrough first. But verifying that the information provided to you is actually what the employee has used. And I can't tell you the number of times that this has happened where I've gotten out to a plant and oops, that's not what they're using. The problem there is you might not have the right sampling media. You might overlook trace ingredients that are there. All kinds of stuff can happen. I'll give you a couple examples there. There's a company client that sprays concrete, large concrete materials used in the construction industry. When the sampling was done, one SDS was provided, but on site, a different one was provided. Now, this is a solvent sampling, so in the laboratory, that can be kind of easy to fix, but the point was the product being used was not the safety data sheet that was provided. In another case, I was out in Massachusetts sampling and provided with SDSs from the corporate people. Get out there, that's not what these people were using at all, and so I couldn't sample for the actual materials that were being used because I didn't have that media with me. And just kind of lastly in this whole what can go wrong thing is if you don't have a good chemistry background, you want to be very careful when looking at substances and maybe rely on the CAS number if you're not comfortable with chemical names. An example of this is 2,3-pentanedione and 2,4-pentanedione. That's one position on the molecule different, and they have vastly different exposure limits. One comes from coffee roasting and food additives and has a really low exposure limit. The other one is used in paints and has a much higher exposure limit. If you don't understand that and you use the wrong exposure limit, you've got a problem there. So it's important to at least have a little bit of chemistry understanding there. Next slide, please. Step 2 is understanding the process. There's a lot of information on this slide, and I'm not going to go into it, but I think the one thing that I've learned most in my career is that I want to understand the process. I want to understand how chemicals are input into the process. I want to understand how they might be transformed in the process. I want to understand who's doing what. I want to understand what equipment and tools are used, so that all of these things are going to help me figure out what should be monitored, what are the most prioritized situations that should be looked at. How long do the exposures last? Are they periodic? Do they occur all shift? Are things used in a confined or poorly ventilated space? What do they use to clean up things? All of this is information that I like to know up front because I think it helps me do a better job of planning for the survey and helping people out by identifying exposures that maybe they hadn't really thought about before. Oftentimes this whole question process gets to be kind of annoying because it's like, wow, that's way too much information here, but it'll help everybody do a much better job. I've just listed a few things on the right-hand side of this slide that I found over the years. If I hear somebody say these things, that's where I'm going to ask a lot of questions. For example, if you have a painting operation, and they're aerosolizing it in a spray paint, that's a way different type of exposure than somebody using a brush or a roller. Dry handling of materials, wow, that's a biggie for me because if you have light materials and somebody's scooping and weighing and dumping, those are all really potentially high exposure tasks that can really drive exposures for toxic things like lead or or cadmium and things like that. So those are just some little things that I've got down on there. Indoor sources of combustion are a big deal with carbon monoxide, especially here up north where buildings get closed up in the winter time. Oftentimes I just carry around a CO monitor with me all the time. And if I see a lot of forklifts driving around, I at least do some spot checks to see if there's an exposure issue. Next slide, please. Again, I won't read through all this. This is more for reference, but I think these are common examples of where details absolutely matter. And in painting operations, it's very rare to find a painting operation where only one paint is used. Oftentimes there's multiple paints, there's multiple components to the paints. And if you're trying to figure out, for example, if you're sampling solvents, which ones to look at, you need to know all of that stuff up front because not all solvents could be collected together. Sometimes if you just ask for a solvent scan because you don't want to figure this all out, you may be missing some of the solvents because not all of these scans cover all of the solvents that might be in a mixture. Welding and thermal cutting, similar thing. You have to know what the method of it being used. Get the safety data sheets for the welding wires and sticks because that's going to be your primary source of exposure. Hexavalent chromium has to be collected separately if you've got high chrome content materials, and surface coatings can really add confusion to everything. Next slide, please. So what can go wrong? Well, you could have the wrong sampling media or pumps or sensors for what's actually used if you don't have this information up front. Also, getting a representative sample may be a challenge because you weren't there on the right day or the right time. And a lot of shops these days are very much job shops where exposures and products change a lot, and it just makes it much more challenging to see. Over the years, I think there's two things that drive variations in exposure. One of them relates to this area, is that production variations are a major reason that you see a lot of variations of exposure, and observing and understanding them is critical to interpreting the data. Oftentimes, significant exposures can be missed if they're done off shift work. I do a lot of work in foundries, and refractory work, removal from furnaces and ladles, is often done on off shifts on weekends. And oftentimes your contact, if you're not that contact, doesn't even know that work is going on, and yet those are extremely high exposure tests. So asking questions about things based on your knowledge of the process can be very important. Next slide, please. Selecting people. Again, this can be very straightforward, but it can be complicated at the same point. You need to identify the employees performing the task and what their variations are. And where I run into this a lot is again, back in job shops, and I'll use a welding shop as an example. Some welding fabricators, they will manufacture a wide range of products, from great big boxes that might involve some restricted or confined space welding to little tiny parts. And those exposures are going to be hugely different. And so if you're trying to get a representative sample, you want to try to get a good array of these exposures so that you can make good conclusions. You want to find out when the exposures occur. And this is probably one of my most frustrating things in industrial hygiene, is you ask a simple question: what is the shift start and end time for each of the employees that you're sampling? And in this day and age, that seems like a simple question, but it's really not. A lot of people have staggered shift starts, especially in COVID times. People aren't all starting and ending their shifts at the same time. And if you're not there at the beginning of the shift when things start happening and you only got 8-hour shift, you can really get lost sample time and shortened samples that then you have to make interpretive judgments. I'd rather have data than have to make an interpretation of what I think happened. And so really trying to nail down shift and start times is really important. If you've got people working 10 and 12-hour shifts, that's really great, because then you can get good solid 8 hours even if you miss some time. Next slide, please. Selecting the sampling method. This is probably the most challenging for a lot of people. Getting the equipment is not that difficult, but in order to get the right equipment, you got to know what sampling devices that you're going to use. And I'm talking here about active sampling methods where you have a pump and then some sort of collection media. The best place to start is with whatever laboratory you're using, and you always want to follow what the laboratory is telling you and the specific laboratory that you're going to be using. Many of them, in fact, most of them have either printed guides or online guides that will tell you what options you have for sampling. But remember, there are oftentimes many methods for a single component, and it takes some judgment or some asking of the lab personnel which is the most appropriate one for your application. If you're sampling multiple analytes at the same time, for example, if you have multiple solvents or multiple metals, these often can be collected on a single sampling device. However, there are the stray ones that don't fit in. For example, the glycol ethers and their acetates can't be collected with most other solvents. Silver cannot be collected if tin is also analyzed. So you need to know if there's these outliers that can't be collected. If you're using filters, are they open face or closed face? That means, does the cover come off or does it stay on? Or do you need a size selective device such as a cyclone or a PPI sampler to do the sampling? Doing sorbent tube sampling is a big challenge. I don't know how many different sorbent tubes are out there, but there's a lot of them. And probably the most frustrating things about those is that they are not all the same size, they're not all the same length, and the diameter is different. You can kind of see in that little picture up in the upper right-hand corner about that. And so it's really important that you know that in advance, because if you need to get a tube holder, your sorbent tube needs to fit within that tube holder. Sometimes you end up with media that creates huge back pressures, and I ran into this with sampling peracetic acid and hydrogen peroxide in food processors, where it's a commonly used sanitizing chemical. I had used what I thought was my Gilair Plus pump that was supposedly had enough ability to have the back pressure of these media, but it kept flow faulting. I had to use a different type of pump that would allow me to collect those samples. But I was in the middle of Northwest Iowa and I couldn't do the sampling because I didn't have the right pump for that. That was my mistake. But looking at the published back pressure capabilities of the pump, it should have worked, but it really didn't work. There's a couple other things on there that you can read at your leisure, but the last one I want to emphasize is always order more media than you need, because stuff happens. You're going to need them for blanks. You get out there and you find, boy, I would really like to do some task-based sampling, and you want to do multiple samples. And if you don't have the media to do that, you can't do that. Stuff falls off and breaks and that sort of thing. And so you want to have backup media so that you can at least salvage your day. Next slide, please. This is just an example from a lab that I used, their lab guide, just to kind of go over a couple of those points. You can look and find out what the analyte is, which sampling media you're supposed to use for it, what storage requirements or shipping requirements they are, and over in that blue box, the compatibility. Are these solvents compatible? And then these, like for example, acetone is an A list compatible, so anything on the A list can be sampled all together. And of course, the CAS number is listed, which is always really, really handy. Next slide, please. So these are just some things that can go wrong. Obviously, if you have the incorrect media, you don't want to use it. You do not want to collect using the wrong media. Yeah, it's just a waste of everybody's time. Sometimes the media has to be connected to the sample pump. And most cases it's easy to do, but sometimes you run into issues where the tubing does not fit correctly. There's a little picture on the bottom of a higher volume flow pump that I use for silica sampling. And you can see that the inlet on that is not your typical inlet diameter that's on a like say a Gilair Plus pump or a Escort ELF pump, MSA pump, or Zephon. So you want to make sure you have the right diameter tubing. You can use adapters and connectors, but I just don't like to do that because stuff can happen to that. Sometimes if you don't plan ahead and you don't have the right calibrator, you've got big problems. Calibrators have flow rate ranges. The newer ones now have really broad ranges, so it's a little better than it was in the past, but make sure that your whatever calibration device you're using will cover the flow rate that you have. If you're sampling, if the samples are supposed to be open face and you collect them closed face, obviously that's a problem, and you need to know that up front. The sample results can't be compared to an exposure limit. This is obviously a big problem. If you're doing sampling with something that has a size selective OEL and you don't use a size selective sampler, that you have an invalid sample and it really doesn't have much meaning. And this again impacts noise sampling. I'll talk about that a little bit later. Next slide, please. Selecting the appropriate flow rate and sample time. Again, this seems like it should be pretty easy, and most of the time it is. All of these lab guides, or certainly the friendly lab people, or published methods that you can find online will have a recommended flow rate and sample volume for that method. The flow rate choice affects your sample volume and sample time. Sometimes there's broad ranges for the substances, but for size selective devices, you have to use the specific flow rate for that device and you can't alter it. For example, PPI samplers come in 2, 4, and 8 liters per minute. You need to use whichever flow rate is specified for that device. So picking a flow rate is critical because that's going to impact two things. It's going to impact how many tubes that you might need, as well as how long the sample can last. So for certain compounds, and I've run into this with methyl methacrylate, it has a very low sample volume on those tubes. And sometimes you need to do 2 to 4 samples to cover an 8-hour shift because the capacity of that tube is just so small. And you need to know that in advance so you order the right sampling media and that you follow the volumes that are specified in the method. There's all these methods have a minimum volume. You want to observe that because otherwise you're going to get some terrible detection limits that limits your interpretation. And on the opposite end, if you go beyond the maximum volume, you could get media overloading. This is not a problem if you're expecting low exposure limits and you can kind of exceed the maximum volume. There's some wiggle room, but you need to know what you're doing in order that. Talk to the lab and ask them in their experience if the published volume is 240, but you're expecting really, really low exposures, could you extend that out and minimize the number of media and therefore your cost because you're not have to have as many samples analyzed. Next slide, please. Again, going back to this particular lab guide, up in red, it has your minimum sample volume and your maximum, and it'll also have the flow rate. Again, for acetic acid, as an example, 0.2 to 0.5 liters per minute, and then you go up to something like alkaline dust, 960 liters, a huge volume. So these are things to always check out. Again, it can be in the online guides or in printed guides that the laboratory has. Next slide, please. So what can go wrong if you don't think about these things first? Well, you may not have ordered enough media to cover a full shift if you have these sample volume limitations. You may end up with detection limit problems. And if your detection limit is above the occupational exposure limit or OSHA action level, now you've got real problems. So let's say the action level is 25 for silica, for example, and you're doing a test-based sample and you're already having, and it's a short sample with a lower flow rate type of sampling device, and you get a detection limit that's 75 micrograms per cubic meter, you have no idea if your exposure, if your action level was exceeded. So it's really important to think about detection limits and always try to adjust your sample volumes to make sure you get above the minimum, that minimum detection limit is above the OEL. I ran into a situation a couple of years ago where OSHA actually kind of cited people for not doing their initial exposure evaluation for diacetyl. They had actually done sampling, but all the sample results were above the exposure limit. And so OSHA said, how do you know that you're below that exposure limit? You don't. And it turns out that when OSHA sampled, they weren't below the limit. So that created some certain problems. If you use the wrong flow rate for size selected devices, you might as well just throw the sample out because it's not worth anything. Next slide, please. Tools and calibration, a lot of information on this. I'm just going to share some experiences so that you can hopefully not do things that I've learned from in the past. I like to have some useful tools on hand, duct tape, painter's tape, and I should add ties that you can use for those plastic ties that you can use for attaching cable ties, excuse me, for attaching area samples. The duct tape I use for all sorts of things that come up in the field. You need to have the right tools if your pumps require you to open a little cover or fix equipment or adjust equipment. Alligator clips are one of my favorite things. You can buy those independently. And I always like to have at least 2 alligator clips on my tubing so I can get a 2-point contact on the clothing of the employee, because that keeps that tube from slipping down over their shoulder, which drives people crazy and leads to all sorts of problems. Belts or vests are very handy. I bought a bunch of belts from a surplus, like an Army surplus store. I actually had them sew them up in a very large diameter to fit all kinds of people, and I just carry them with me and I always have them available so that I can mount the pump on a belt, because there's a fair number of people who don't wear belts, and those pumps will drag their pants down and be quite embarrassing and uncomfortable for the employee. Many people use sample vests where they can drop the pump in a pocket of the vest and then have the put the collection device on it. Those work great. Just remember that they can get really dirty and maybe you have some decontamination issues you have to think about. A couple of other things is play with the equipment so that you know what it does. Inspect it. Up in the corner there in that middle slide is a PPI sampler that came from a laboratory. You can see that crack running right down it. They came from the lab that way, and obviously that's a leakage problem and is going to create issues. To the right up there is a Gill-Air pump where the belt clip got bent from the employee. That will not go back in the docking station until that clip is bent back into position. So just be aware of those things and make sure. Clear and zero instruments before sampling will make your life a whole lot simpler. Next slide, please. On-site equipment placement. This is just a super critical thing. I always try to be super respectful of the employees and not get too upfront in their personal space, although that can be a challenge. But I try to do my best to make this as pleasant of a process as you can. Identifying people ahead of time is really advantageous, but be prepared to have a backup plan. Be prepared to show up at shift start. I can't tell you how many times I've seen sample start times that are an hour or two after the shift started. You get 340-minute samples and people are comparing them to 480-minute time periods. In my opinion, that's just sloppy industrial hygiene. You need to be there for the whole shift because stuff happens and a lot of important things happen either at the beginning or the end of the shift that can really impact exposures. And if you're not sampling that time, you're not really getting quality data. I always explain to the employee what I'm doing. I try to keep it as simple as possible. It's not a chemistry experiment. I'm just telling you, here's what you have to do if you have problems with a contact, that sort of thing. A couple of highlights I want to hit here are on collection device placement. It goes obviously in the breathing zone, so you want that sampling device up close to the person's head, or in the case of noise, up in the hearing zone. I've seen people get ticked off at the sampling device and tuck it, especially dosimeters. They'll just tuck it into a pocket or someplace else and move it because they're annoyed by it. So just something to be aware of. If the person's wearing an air supplied or PAP or hood, the device has to go outside the respirator unless for some reason you want to know how well that hood is working. Welding samples, the device is supposed to go underneath the welding helmet, a big challenge. Clothing, some in weather transition times, or if somebody's working indoors and outdoors, they may be taking jackets or sweatshirts or sweaters on and off. That device has to be on the outermost layer of clothing, which again becomes an important reason why you want to do observations, so that if those things happen, you can readjust where that collection device is. You don't want to sample under the jacket. That's kind of useless. Placing area samples in safe, stable places is always a good idea. Look out for moving equipment and things like that. Pump and tubing placement, usually the pump goes on the waistband or in a vest pocket. If the person's wearing coveralls, that can be a little bit of a challenge. Sometimes the tubing is too short. And looking out for reasons that the tube could kink at the pump inlet, because that'll flow fault the pump, and then you got, again, interpretation or short samples. Sit down jobs, whether it's a chair or a seat in a heavy equipment vehicle or an office or assembly job, that tubing can get caught and the pump can get screwed up if somebody sits down. Airline and papper belts, you can kink the tubing super easy. Fall protection, same thing. And lastly, a person's weight. Sometimes people, when they're very heavy, I hope I'm not offending anybody, but placing that pump can be a little bit of a challenge. Or if somebody's really tall, sometimes your tubing isn't long enough. So being prepared for those situations is helpful. Next slide, please. These are just some examples of placement. I won't dwell on them, but in that sample in the picture on the left-hand side, you can see that that sample tubing is underneath his papper belt, so it stays nice and stable. It's not getting pinched or kinked at the pump. There's a 2-point clip up near his near the end, and you can see that that sampling device is placed outside his papper helmet. In the second picture, I put this one in there mainly to emphasize this was an outdoor job. This was cold morning in Wisconsin, and he started out with a heavier clothing on him, and so I had to reposition the sampling device during the day to account for that. And lastly, the bottom picture is just another example of a cyclone outside of a air supplied hood. Next slide, please. Lots of things can go wrong here, but I guess I want to emphasize a couple of them. Employees sometimes think these devices are spying on them and may alter their behavior. That's a communication issue, and trying to assure the employee that you're not spying on them or trying to figure out what their production rate is or whatever, and try to reassure them that this is for everyone's benefit. I mentioned before about collection device and placement issues. If the tubing gets dislodged, you're not collecting sample, that's a problem. I've had problems with people taking off their devices at break time and just putting them wherever, and you lose control over the devices, so that can happen. Sometimes you get just people who get annoyed by wearing the equipment and they want to just take it off and leave it. Hopefully you got a supervisor there who can tell you that's happening, or more hopefully you're out there watching and can address those concerns. This bottom picture is an example of what happens to a Giller pump that goes through a shakeout in a foundry. It fell off the employee on my next round of checks. He never said anything. Someone comes in and tells me, hey, there's a blue thing going around and around on the turntable, and it was my destroyed pump. So that was an example of just stuff that happens. Next slide, please. Observations. I think if there's any message that you remember from what I said today, is that numbers without context are, in my opinion, useless. You have to make observations, which means you have to make time to just watch people work. I know that that's kind of annoying, it's kind of stressful, it's kind of boring and tiring at times, but you need to be watching what people do, because what people do will just amaze you sometimes. And they really, their work practices, how the equipment's working, how the controls are working, all are just super important things that tell you a lot about what that sample is going to mean at the end of the day. I've just listed some things that I think are important to note. Super important are process disruptions or usual things that happen. One day I was out sampling in a foundry, and the guy up on a mezzanine decided he was going to do some housekeeping work that normally is not done during the shift, and down come clouds of sand, and there was a molder working right next to him, and he had very high silica levels. Again, it was not a normal normal thing that should have been done, but it impacted. At least I could explain why a guy who should have had high exposures had high exposures. Again, some of these other things to think about is if the employee leaves for the day, do you switch the device to another employee? If they're doing the same job and they're similar jobs, I don't see a problem with that. You just need to document that that's the case. I've listed a whole bunch of sample device problems. Pump stoppages are probably the most frequent thing that happens. Sometimes you can salvage and fix the sample, other times not. And this little picture here is what happens when you get sparks from an arc gouging process flying into a cassette. It melts the plastic media. So, you know, stuff happens and you just got to move on from that. I've had issues where the filter falls off the tubing and the employee, trying to be nice, puts it back on, but they put it on upside down. Again, sometimes you can salvage that sample and other times you can't. Next slide, please. Your post-sampling steps, not a lot can go wrong here other than I really suggest inspecting the media, making sure that it's still intact and good and nothing weird happened to it. You need to be sure to prepare a field blank and submit it with your samples. Make sure you accurately calculate your sample volumes and fill out your chain of custody form. Remember, it's not the lab's job to figure out what you want analyzed. That's your job. And going back to those OEL things, you need to know what your what you're asking to have analyzed. And if there are shipping requirements like shipping on ice or overnight, you need to be sure that you prepared and had the ice and the cold packs in an insulated container for that sort of thing. Next slide, please. Interpreting results. Oh boy, this is a big subject, but one of the things I recommend always is reading your lab report and looking for any notes about the samples. For example, were they overloaded? Was there breakthrough that occurred? Things that would really impact how you would interpret the result. If applicable, calculate time-weighted averages. I'm a big believer in using significant digits. You know, these numbers that you get from active sampling as well as direct reading devices, they aren't significant beyond about the first or second digit out to the right. So don't have lots of those numbers. Rounding is acceptable to whatever the laboratory determines to be appropriate. Make sure you're comparing it to the correct OEL. Review your observational data to figure out what the results represent. And if there are things that happened during the shift that could have impacted. When I write reports, all of that's in there so that somebody reading it can go, oh boy, that was way different than what's normal. Maybe we should resample that again. And then communicate the results to management. Certain OSHA standards have time requirements for communicating that, but for the majority of substances, it's up to the employer to do that. And I always encourage people to communicate the results with employees. Next slide. Things that could go wrong, a couple of things I just want to hit on because I know we're getting short on time here, is calculating your time-weighted averages. I'm a big believer that if you don't know what happened during the non-sampled part of your shift, you shouldn't be calculating time-weighted averages. And if you have more questions on that, I'd be happy to converse with you about that. Comparing the results to the wrong exposure limits, we've already talked about that. In noise data, there's 3 different ways, primary ways of doing noise assessments, and I see people comparing their noise results to the wrong exposure limits all the time. For example, they'll get a time-weighted average of 90 decibels, and they're comparing, they say that, or say 92 decibels with the hearing conservation level settings, and they'll compare that with the PEL. You can't do that. You have to compare apples to apples with this, and this is probably one of the most frequent things that I see people doing with noise reports. You need to acknowledge your data limitations and what the numbers are telling you. And lastly, just as a warning, relying on one set of samples to make broad judgments about exposures is always dangerous. So the more data you have, the more confident you can feel about your exposures. Next slide. So this is just a summary. I won't go over this because I think you can read this on your own, and I know we're short of time. So let's have some questions, Matt.
All right, let's see what we got here. Got one here. Which pump did you use for the problem with the back pressure? Peracetic acid is difficult to sample since the method requires 2 sampling media in series,
Yes.
and it always
That,
faults.
yeah, that's correct. The last time I think I actually rented this from you guys, I think it was one of the SKC pumps. SKC makes a pump that has a really capability of having a real high back pressure. I'm not sure what the name of that pump is. Do you, Matt? I could go back and look in the report, but the SKC does make a pump that can handle that amount of back pressure, and it worked really well when I did that sampling.
I think it's the 5,000 unit, if I remember correctly.
Yeah, could well be.
Okay. Well, that's all I have, and since we are kind of running into the hour, we'll go ahead and end it there. Let's see. Okay, thanks again for the presentation. If anybody has any specific application questions, feel free to call me at 866-RENT-EHS or 866-736-8347. You can also reach me by email at matt@raecorents.com. If you want to know more about the technology supply, please follow us on social media. We put out a lot of good technical tips in my blog, blog.raecorents.com. You can also follow us on LinkedIn and Twitter. We record all these sessions, and I also put it in the handouts for today. If you can grab it, the presentation there as well. So at this point, no further questions. The presentation will conclude. Thank you all for attending, and thank you again, Kay. Appreciate
You're
it.
welcome.
All right. Have a great day, everyone.